All right, let's do our science. Nope, not that. Our science digital lesson. I feel like it just disappeared on me. Hang on. There it is. I knew it was hiding behind something. Okay, today's lesson, it gives us an introduction on sound. I'm going to go away.
Play ball. Attending a baseball game is noisy fun. There's so much activity going on everywhere. Click the highlighted areas to learn more. When you're done, click the next button to discover more about sound. People in the crowd get louder as they cheer for their team. You can hear the excitement. Crack! Did you hear the sound of that hit? What other sounds do you hear at a baseball game? People in the crowd talk softly while they wait for some action on the field, but the vendor yells out to make sure you can hear him. Welcome to the lesson. What is sound? In this lesson, you'll learn about sound and why sounds can have different pitches and volumes. The vocabulary words for this lesson are energy, sound, vibrate, and pitch. Click each word to find out more about it.
All right, let's take a look at these words. Energy is what we're looking at in this whole unit. The ability to make something move or change. So the last lesson we learned about energy was about light energy. Today it's just a different form of energy. Oh, let's see. Okay. Sound is energy that you can hear. That's pretty easy to figure out. Let's look at vibrate. Vibrate means it moves back and forth very quickly. The picture example they've given is a cymbal, and I think we're going to see why they did that later on in the lesson. And the word pitch means how high or low a sound is. So he's playing on a xylophone, and if he goes to play up here on the high notes, the sound is up high, and down here the sound is low. That's the difference in pitch.
When you listen to music, you hear high and low sounds. You also hear loud and soft sounds. The changes in sound are what make music sound great. Energy makes something move or change. Think about banging on a drum. The drum head moves back and forth quickly. In other words, it vibrates. That vibration makes the sound we hear. So what do sound and vibrations have to do with energy? Sound is energy that we can hear. Click play to learn more.
Okay, here's how the cymbal's going to show us. Let's see.
In this slow motion video, a drummer hits a cymbal with a drumstick.
Whoa,
This causes the cymbal to vibrate. The vibrations make waves in the air. The waves travel through the air to our ears, so we hear sound. Vibrations make sounds. Each of these images shows something that can make a sound or sounds. Click each image to see what is vibrating to make the sound. Crickets rub part of one wing against parts of the other wing. This causes the wings to vibrate. You hear the vibrations as a chirp.
Did you know that a cricket's chirp was caused by their wings rubbing together? That is not how I would picture that sound.
A wind chime is made of different sized pipes. The wind knocks the pipes together so they vibrate. Each one chimes a different note as it vibrates. You can't see what vibrates here, but you can feel it. You have vocal cords in your neck. They vibrate when you talk or sing to produce sound. Place your hand gently on the front of your neck and sing. Do you feel the vibration?
Okay, I want you to do this with me, okay? You probably learned this in kindergarten when you were learning which letter sounds are voiced and not voiced. So if you put your hand right here on your neck and you talk like this, you can feel the buzzing. Even if you couldn't hear, you'd be able to know that your voice was making noise. Try it. Experiment. Which sounds can you feel and which sounds can you not feel? Unvoiced sounds like S, can't feel that. T, can't feel that. B, b. Oh, so like it's like a whisper versus talking. If I whisper, I can't really hear that. I can't really feel the vibration. Whispering does not cause the same vibration.
Here is a power tool and a piece of wood. They make a lot of sound. When the tool touches the wood, both the wood and the motor vibrate. In these images, what object is making the sound? Drag each label to the correct image.
Okay. Here's the drums right here. Oops, missed. The hands are clapping together and vibrating the sound. Tearing the paper makes vibrations in the air and the paper, and vocal cords. Even dogs use their vocal cords to vibrate for sound.
Good work.
Thank you.
You know that things vibrate to make sounds that we hear. You know that vibrations make sounds. Some vibrations are faster than others. Fast vibrations make high sounds. We say that these sounds have a high pitch. Slow vibrations make low sounds. These sounds have a low pitch. Click the highlighted numbers 1, 2, and 3 to learn more about vibrations and pitch.
Okay, let's look at these low notes down here.
The mallets strike the bars. This causes the bars to vibrate. This time, the musician begins by playing the longer bars. The long bars vibrate more slowly. They make a low-pitched sound.
So the longer it is, the more slowly it vibrates, and that is what changes the sound to be low. Let's look up here.
Here, the musician starts out playing the shorter bars. The short bars vibrate quickly. That's why their sound has a high pitch.
Okay, just a minute. Oh wait, this is the thing. I have to do this button. It's always this one that gets me.
Loud sounds need more energy than quiet sounds. Think about how a harp makes sound. The harpist plucks the strings. The strings move back and forth. Click play to learn more. The harpist plucks the string with a lot of force. The string vibrates over a large space. The sound is loud. In other words, it has more volume. Click play for an example of less volume. The harpist plucks the string gently. The string vibrates over a smaller space. The sound is quieter. In other words, it has less volume. Click play to compare volume and pitch. Pitch and volume aren't the same thing. This is a low-pitched note. The string vibrates more slowly over a longer length. The musician can play it loud or soft, but the pitch doesn't change. This is a high-pitched note. The string vibrates more quickly over a shorter length. The musician can play it loud or soft, but the pitch doesn't change. Loud sounds need more energy than quiet sounds. Think about how a harp makes sound. The harpist plucks the strings.
Okay, so I'm going to come back for this. So what they told us was vibrations with more energy gives that energy determines the volume. Okay, so the more energy you put into it, the louder it will be, which makes sense because it's a lot harder on your voice to talk loud. If I talked like this really loud all day, my voice would get really tired. Okay, and I can use less energy to talk in a quiet voice, which is why, like, when people are sick, they usually use this quiet, wimpy voice because they just don't have the energy. Okay, so energy means volume. So vibrations with more energy are going to make a loud sound. Vibrations over here with less energy is going to make a soft sound. Now, remember, the speed of the vibrations, not the energy, but how fast they vibrate, that is what determines the pitch. So slower vibrations gives you a low pitch. And really, really fast high ones. See how that works?
The strings move back and forth. Click play to learn more. Which of these make high-pitched sounds? Which make low-pitched sounds? Sort the images. Drag any image to begin.
Okay, what do you think about the cow? I'm hearing it in my head. Is it up a high pitch or down low? Moo, that's low. Okay, what about a croaking frog? Ribbit, ribbit. Or is that a toad? I'm not sure. What about a bird? Bird twittering. Yep. What about a piccolo? Piccolo goes. Yep, that's a high pitch. Okay, a tuba makes a low sound. And look at the difference in the sizes of the instruments. Think that has something to do with it? And the little mouse has a high little squeak.
Good job.
Thank you.
High-pitched sounds, like the sounds made by the bird, piccolo, and mouse, have fast vibrations. Low-pitched sounds, like those made by the bullfrog, cow, and tuba, have slow vibrations. You've learned a lot about sound. Let's review the main ideas from the lesson. Sound is energy caused by vibration. You can see some sound vibrations when you watch guitar strings as they're strummed. Faster vibrations make higher pitch sounds. Some examples of high-pitched sounds are a cricket chirping and a small bell ringing. Slower vibrations make lower-pitched sounds. Some examples of things that make low-pitched sounds are a tuba and a cow. Volume comes from the amount of energy in the vibration. A vibration that moves over more distance makes a loud sound. A loud shout has more energy. A vibration that moves over less distance makes a soft sound. A quiet whisper has less energy. Now that you've finished this lesson, if you wish.
All right, so I wanted to show you with my ukulele, and I'm going to hold it up close and see if you can see the string vibrate. Okay, make sure it's still and centered. Are you ready? Can you see it moving? Let me try this middle one. So if I pluck it with really hard, that's loud. But if I just go, okay, it's still vibrating at the same speed. Okay, no matter how hard you pluck it, it still uses the same speed, which is what creates the pitch. So no matter how hard I do this, it's gonna vibrate at the same speed because it's the same note. Okay, but if I hold down the string sorry, I'm trying to figure out the distance. If I hold down the string by pressing it right here, that shortens the amount of string that's going to vibrate, and that does change. So right now it's just, okay, but what if I hold this down? You see how that shortened the string? It didn't give it as much to vibrate, so it's a